starting off giving or as giving you another overview where statistics, giving you another example where statistics was immensely used about COVID-19 analysis. What are the hotspots the disease is being so viral, and likewise the number of deaths happening, number of recoveries, various aspects of the same scenario. So COVID-19 pandemic data can be with respect to the deaths, survivors, incidents, and recoveries, or there's various variables or aspects that you can consider. Right. So this is about Sri Lankan situation about the number of cases with respect to the monthly, daily cases reporting, right? And total cases, active cases, recoveries, daily increase, and the fatal cases. Likewise, there's various aspects that you can consider of the same application or the same problem, right? So if I just ask, if there was no subject called statistics and you didn't know about this calculation of probabilities, calculation of averages and median values, what would happen, right? So if you didn't know about statistics, you wouldn't know who is going to win the election. As in, before an election, we would do some predictions to do some to do something in advance. As in, if the depending on the government that's going to be in the country, the business community make adjustments to their business practices, knowing the different governments, different economic policies, right? So sometimes rather than waiting till the last moment until the president is elected, they want to know, it would be good for them to find out who is going to win the election in advance so that they can be prepared beforehand. Right? So for that one, they would collect data from the people who are going to vote and get a rough idea or get the estimated percentages of votes that each candidate would get, and have a estimate, as in there's a 80% chance this person is going to be the president. So we would be adjusting our business plans in accordance to that, right? And also, let's say you are doing some flight booking, right? So without statistics, you would have to search the internet one side at a time, as in you go to this particular person's airline site and then to the next one, and but when the data is together in one in a one portal, or you can do a Google search and get all these details in one go, right? With less time, right? And in other, not really in countries like Sri Lanka, but in other countries, the people before going out, they would be checking their weather predictions. So if the predictions are going to be having a very cold weather, they would go in suitable dresses, right? And with suitable footwear, and likewise, right? So those decisions, that's in weather predictions, are given by analyzing past weather data. So that's about so for highlighting why we learn statistics, right? As I said, many of the decisions that we make every day are based on statistics. For example, you want to make a decision whether to come to the class today or not. So you have gone to the class like 5 or 6 days before, and you will analyze what happened in the class. Did I understand the subject? Did the teacher give any quizzes or assignments, right? And then you make a decision whether to go to the class or not. You may not realize, but it is statistics that comes into play. You will think of chance that the teacher will give a ad hoc or a like instant quiz so that you will miss the marks, right? So the class had been done previously for 10 days. Out of that 10 days, 6 days the teacher has given such quizzes. So there's high chance to get a quiz today also. So I will not miss the class. Right. And I would say the era that you are now living in, I mean, like the people in this new generation, it's a great time to be a statistician or I have to get my it's a gate. It's a great time to be a statistician, data analyst, or a data scientist. Why I took these terms is that now the industry or the corporate sector mainly use these terms like job roles are being considered data scientists, where it is not only statistics but computer, mathematics, and things are coming together, right? The reason is that there's a high demand for data scientists or statisticians is that we get very high volumes of data in such a very high speed, as in social media, in the Google Forms and loyalty cards, Uber records, and other online booking, online purchases. Likewise, data is readily available in electronic form, where we can straight away start on with data analysis and give out decisions based on data. But in the olden day, you will have to make a sheet of paper, go through companies and collect data, meet customers, and go to the grocery stores and collect data. But nowadays, data is readily available. But with one click of with just one click of it, you can download and start analyzing data. That's why there's a high demand for analyst or data scientists nowadays, right? So be happy that you have been fortunate to get selected to a degree program where you also have the potential or the chance to become a data scientist or a data analyst or a statistician. Do a Google search about how the statisticians, data analysts are being paid, average payment, or the salary scales. Compare the salary scales between engineers, mathematicians, statisticians, data analysts, and try to understand where you stand. So I want to stress this out, children. You have got really good experience. Not that I'm from the statistics department or I'm teaching statistics. We have encountered very many students who do special degrees or who do even in general degrees, who have followed statistics, have secured good job opportunities. You believe with me, you wouldn't be the salary that we got in about 3-4 years, that the salary that your parents got only at the end of their service completion, like towards when they are at their retirement, you are able to go for a job right from start after graduating. But you should have the qualification in hand, as in secure good class in the degree, first class, second uppers, like that, and other skills and competencies also should be improved. But you have time now because this is just your beginning, right? So as I said, tools are getting easier to use. Tools means statistical softwares. Earlier we had to purchase very costly statistical software, but now open source statistical software are available, so that you don't need to worry. Sometimes in the web also, even you don't need to download the software and get the data analysis, but there are some apps available, some web options. Someone's mic is disturbing us. I can't find who that is. Kindly mute your mic, please. Right. And there are a lot of data-driven organizations setting up in the country, as in they are the data analysis companies, right? When we were graduating, you call as what you call as the data analysis companies, but now it's called like data science companies, data scientists. Our students also get good opportunities in these startup companies, where they are working not on Sri Lankan data source would be their clients are international clients. So we are very happy to see our students are working in these companies and working from Sri Lanka itself. They are contributing to the Sri Lankan economy in great deal, right? So this is now the situation in the country is a good situation for us to understand how the collective effort of all the people counts in. As in, if you just do a job which gives you money flows in just to you, right? Not just it caters into the country's development. Then if the country is collapsed, no point in you developing on your own only. You have a salary of 100,000 millions, but what if the country is collapsed? No point in having such a surplus of money, right? So these data-driven organizations, which will be starting with 1 or 2 employees, right? You also, once you graduated, you also can think of starting a company. And also while you are in the university, also look for opportunities where you can work on remote basis without making it a disturbance your academic work. There are projects where you can join in as at least after doing the first year, doing some small analysis jobs and earn some money, right? So it gives you an experience into your CV as well, right? So there are various such opportunities for you children, right? All the thing is you should all have some interest or passion for your self development, right? So why statistic has been so popularly used is that due to this variation, as in if the same thing is happening everywhere with every person, the conclusions or the decisions would be solid. As in you are going to start up a supermarket store and you want to know how many bundles of let's say some high let's say frozen foods to be kept in your ordered monthly, and they would if the sales the ordered quantity and the sales doesn't match together, it's a waste to the grocery store, right? So but it is not a fixed value that not every month you would get 10 kilos of frozen meat. So it would be 5 kilos one day, 10 kilos one day, and it would go to 30 40 in April or in December due to the festive season. So there's a variation in the happenings around. So your decision should adjust to this variation in the practical situation. So in such cases, statistic is the tool that you can use to make decisions when the things or when the patterns are changing or variating, right? Okay, so that's all about introducing where we stand and what statistics can do. To start with the subject contents, I'm using this example. Let's say you are buying some items, let's say like light bulbs. They are coming in packs of 50, right? Or as let's say items are coming in packs of 10, and these are the number of defectives in 50 batches. In the first batch, 3 defectives were there. In the second one, 4 defectives, 7, and one in the next few. Likewise, the data is about the number of defective items in 50 batches or 50 orders, let's say 50 sales or 50 purchases, right, of an electronic component purchased or produced in a company, right? So what can you say from these numbers, children? Anything that you can say from this number? Please share with me. Share with me if you see any facts from this. Can you please share with me? So 5 responses so far. Okay. So I'm reading out the answers that I got so far. Any other answers are most welcome, children. Please coordinate with the class. Otherwise, it's a waste of time from both them, yours and mine. So as Devin says, the data is unorganized. All right, because you see data coming from here and there, once here and then 3 here. Just the data is given as batch wise, like in the first one 3, likewise. Okay, and then Senuri says it's hard to get an information from this sort of a data representation. So Yashoda, good to hear from you. I was looking for you before. So he says it's almost nothing that we can get. These are set of data, as Atik says. Yes, this is a set of data. What I think what you want to say is it's a set of raw data. Yes, Atik, that's a raw data set. Extracting data without any analysis is hard. It is, we know, not extracting data, extracting information without any analysis, as in without any calculation, is hard. Then Banu, I also was looking for you, Banu. I think this is not a good data collection for something, for say something. What do you mean? I think this is not a good data collection. You mean data is from Banu? Or you can't say anything from this data without doing any further calculation. So what do you say? All right. Isumi says, we can't gain the information from this data kind. Hard to analyze these data. Only a set of raw data from Saranga. We don't know how many components are there in 50 batch to analyze about the 50. Okay, that's another fact, that is, we don't know the quantity within a batch, as in with just a batch has 20 items or 10 items, right? Okay, grouping up batches according to the number of different years, Kasundi, that's something that we can do to organize data. All right. So I'm so happy for these responses that I'm getting. Yes, Nimesh, I think there are numbers, defective items in 50 batches. Yes, these are the number of items. Yes, these numbers show how much electronic compounds in one batch. Yes, that's what the data is. So that's called data description. I'm asking you any kind of idea or any kind of decision or understanding that you can get from this data. So I would see, when I just see that one was mentioned, 3, 6, 7, 9, 10, 11, 12, 13, 14, 15. So like 15 times the number of defects had been 1, something that I see from my eye, right? But that is all because it's only 50 values. But if I can't say if the data was given for 100 or thousands of batches, right? So those are the restrictions with making decisions from raw data, right? One thing that you can find out, what is the minimum number of defectives. You can say it's 1, and the maximum number, examining, going through these numbers, you would say it has been 50. That also is hard to do if you had a large data set. All right, Banu, that's okay. Right, we should arrange this data for, yes. So one thing is, before moving on to analysis, summarizing or organizing data is also important. As in, you can order in ascending or descending order and find out what is the minimum number of defects had been, the maximum number of defects had been, or the most frequent number of defects had been what. So likewise, in order to get some understanding from data, you have to do something extra or something to the raw data that you have in hand. That's what I want to highlight here, right? So to get interesting features from this data, you should either organize, summarize, or analyze the data. The second three components I said as roles of statistics, right? So in order to do that, in order to organize or analyze data, we would either use descriptive methods, like the methods used for summarizing the data, calculating average, calculating the median, calculating the mode, or making graphs, making a histogram, making a bar chart, pie chart. So those are called descriptive method. And the other thing, the next step in a statistical analysis is inferential statistics, where I would be introducing you the two basic methods of statistical inference, confidence interval building and hypothesis testing, in the last 2-3 days of the course. But detailed methods for inferential methods will be taught to you in the second year under the course Basic Elements of Inference. All right. So a proper statistical analysis would start with this. This will be the first thing to do, and this is the next step in a statistical analysis. The difference between these two is, in the descriptive method, we are explaining the features of the data. So our decisions are all for the data set that we analyze, right? If you analyze another set of data, for example, I asked the students in the class today, did you have breakfast, right? And 80 students say yes. And next day, I'm asking the same question, and it was 70 students. So the percentage of students having breakfast before the class is 80% one day, 70% another day. And then if I ask it in another day, it would be a different one, right? But let's say you want to make a decision about the whole batch, not like today's students, tomorrow's student, likewise, right? So from the information that you get from the today's class, I'm going to make a estimate. Today, the percentage of students who had breakfast was 70%, but you would do some statistical methods and say there's a 95% chance, or I would say in 95% confidence, the proportion of students having a breakfast before the class will be between 60 to 90%. So that's called inferential methods, where we are using the data of the sample to make a decision for the population. For example, sample is the students who are in the class today. Population is the whole IS students batch. Say like only 10 students came to the class, whereas 90 students didn't come to the class. So I'm using the data from these 90 students to make a decision about the whole batch. That's called inferential methods. Right. Then another example to highlight what statistics do. These are the marks obtained by 2 students for 3 subjects. So on the basis of these 3 subjects, we would say the average mark of the first student is 53. The average mark of the student B is 59. So we would say, with respect to these 3 subjects, the performance of student B is better than student A. But let's say that there's a few more papers to come in, so the story would change. So this is called descriptive statistics. We are explaining or make a decision about this data only, nothing more, because we have just calculated the mean only. But if you calculate a confidence interval or a hypothesis state, those are called methods of inferential statistics. We can make a general comment about the student A and B, saying that student A is better than student B, or the other way. But for this from this data, if you just calculate mean only and say A is having a mean of 53, B is having a mean of 59, what we can say is, for these 3 subjects, performance of B is better than A. Is it clear the difference between inferential and descriptive, children? So in the chat, write a sentence on your own. What is the difference between descriptive statistics and inferential statistics? So that I can correct, or I can see whether you have understood. So this is what I am explaining. So far no answer from your side. Is it not clear, children? What I'm asking, the difference between descriptive statistics and inferential statistics. If the question is not clear, tell that and clarify. Okay, one answer. Yeah, so Kasundi, first part of the answer is all correct. For the next part, it has to be the inferential statistic is about making assumptions or reductions from a given set of data to the large population. Okay, so making decisions for the large population, that means the large batch, using the data of the sample. Okay, we know. Descriptive statistics summarize the data set. Inferential statistics assess whether your data can be generalized. Yes, good. Okay, so in summary, so any other answers? So, Danuka, so you are saying you prefer inferential statistics because we can get proper idea, right? So to make that answer more complete, Danuka, you can get an idea about the population or general idea using inferential statistics, not only from the sample that you analyze. Is it clear, Danuka? Why you favor inferential statistics would be because you can make decisions that is common or general to everybody, not only for the data that was analyzed. Okay, then I don't, 1880 something, I don't, it's Gimhana, yes. Descriptive statistics, we describe the data set in hand, as in the sample that we analyze. Wiring descriptively summarize the characteristics of a data set in hand to give your data into a broader population. Right. So make it more. Your idea is correct, Wiring. So allows you to make decisions into a broader population. Not that you give data. It has to be that it allows you to make decisions or understanding about the broader population. So Gimhana interpretation statistic. No, not interpretation, Gimhana, inferential statistics. Okay, Gimhana? Nimesh? From this way, we can get a very good decision for a real matter. We can trust it more than getting decision. No, so the better terms, Nimesh, from a descriptive statistic, we can get a decision for the data set or the sample that we analyze. With inferential statistic, we can confirm, or we can get better understanding for the whole population or the general population, not only the data set that you analyze. I'm really happy that many of you are giving me answers in the chat. Lakshan or Lukshan, sorry if I pronounce it wrong. Using this tool, that is, we can make decisions only using available, but using inference we can predict future progress. Yes, Lukshan, that's correct. Prediction is also a part of inferential statistics. In summary, in descriptive statistics is limited to the data that you analyze, whereas inferential statistics is going beyond that. In terms of the sample, you can go for population. Atik. Okay, summarizing. Then test a hypothesis. Yeah, the hypothesis. So Sashini, the hypothesis is regarding a population, as in not only the data set that you have in hand. We are using sample data from a large batch. Using no, Kavindu, it is not Kavindu, right? In descriptive statistics, we are organizing and summarizing the sample data. In the inferential statistic, the data is same, right? With the same data, we are making decisions about the whole population, about the whole data which we have not collected. Kavindu, is it clear, Kavindu? So you... Okay. Then descriptive statistics. So chat is moving up because many of you are giving answers. Good, my good class. Now I'm going to label you as a good class. So this is the data that I'm using. I'm using the data of the students who are replying today to my chat, my question. Kavindi, I went through your Kaviti. Statistics, we take an idea about a small batch. In inference, predict about a large batch. Yes, using the sample data, that's right. Shavinde, descriptive statistics mean collection of data and summarizing them and provide description. Make predictions or make predictions about a large batch or general or common predictions about the whole population, not necessarily the data set that you analyze. Vihangi, descriptive method is focusing on the current situation. Inference statistics gives prediction about the future. So let's say that's kind of, if it is like time-related data, as in you have the price of fuel or petrol prices so far, and you calculate the average price and the lowest price and the highest price, that's called descriptive analyzing the data up to now. And if you are using other methods and you can predict the fuel price next day, next month, likewise, those are belonging to inferential statistics. So not limiting only to the data set that you have collected. Tikshana, in descriptive statistics, we are analyzing only the data sample we got. But in inferential statistics, we are having an analysis in a broader way. Broader in the sense, statistically, what it means is, it applies for a larger community or larger population. Sanuri, descriptive method is used to summarize information about samples, but we can make any conclusion. We can't. Inferential method is we are using sample to make. Yes, that's right. Tusal, statistics, there are only summarize, organize. In descriptive, there are only summarize, organize a large population. We can remember. So Tusal, need a little bit of change in your answer. The descriptive statistics only applicable, or the decisions that you get from descriptive statistics is only true for the data set that you have collected, not for the data that you have not collected. Inferential statistics, the decisions or the analysis are applicable or true for the larger population where you have not collected data also from. Did I make it clear, Tusal?
Yes, madam, I got it.
All right. Saranga, in this case, we got an idea about the present or past situation, but in happen future. But yes, okay, good. Display ASIC, way that we represents the data at the current situation in the more than which studies the part of the data and gives prediction. Yes. Oh my gosh. Now you tell me that Mihiri. Through descriptive statistics, we can get decisions. So through inference statistics, we can clear about them. No, Mihiri, you have to say correctly that the descriptive statistic is only applicable for the data set that we have collected. Right? Inferential statistic decisions are applicable for the whole population, whole set of individuals. Pasindu, descriptive statistic is where we summarize the sample set, not looking to gain any conclusions beyond the sample. That's true. Whereas inferential statistics, we mean this is the whole population. Good. This will give us, then I'm going through Rashmi. Then I'm reading out all these things. Descriptive set giving summarize of data. Inferential set gives us required percentages. No, Rashmi. Descriptive statistics give a summary of the data. Yes, that's true. Inferential statistics give understanding or provide you to make decisions for the whole population or the data set for the whole batch where you have not collected, including the ones whose data that you have not collected. Right? Rashmi, is it clear?
Yes, madam.
Okay. So my understanding is that giving this kind of exercises is so good. Otherwise, I would be continuing my Bana sermon going on preach like, because all these slides and everything is there with me. I can go for hours and hours, but I don't get a picture of the students. Right, I was at Hasini's. Now, descriptive statistic is summarizing data situation. The data applies to broader population. Good. Sasindu summarize and describe data. So Sasindu, I'm asking, yes, inferential statistic allows to make predictions. Yes, okay. Nimesh, getting decisions by using info will be dependent on knowledge of people. It is not Nimesh. The inferential statistic use the same data, but what we don't use the knowledge of people. We are using advanced methods which are based on the probability theory, as in if the sample was this, how probable the sample to be the same, right? If it is highly unlikely, we would say it is not true for the population, even though the sample says this. So we have statistical techniques for that, right? Thereafter we don't use any data, only the data that same data we are using, but our techniques will be different. They will use probability theory, statistical models, and likewise to come up with decisions for the sample, right? Sorry, population. Hashini, descriptive means make decisions with the data we have. Yes, everything is with the data we have. Only thing is where decisions are true for. So descriptive decisions are true only for the data set that you have collected. Say you have collected data from 50 people. The decisions from a descriptive statistic is true only for that 50 people. Whereas inferential statistic the decisions from the inferential statistic apply to the data that entities that you have not collected data also. Right, Hashini? Say I collect data from 10 of you and asking how do you like to be the president of the country? But I'm not going asking this question from the whole students in the class. I randomly pick 10 students from the list of the student and ask. From that, out of the 10 students I asked, 8 of them said, yes, they like to be the president of the country and save this country. Then that is a decision only about the 10 people. The story of the other students who did not answer or take part in the survey will be different. So what inferential statistic is, if it was 8 out of 10, what would be the percentage, a probable range of value for the population to be the president, right? So if it was 8 out of 10 means it's like 80%. So you would apply some statistical techniques and tell in the population, this percentage of students who are willing to be the president of the country will be between 60% to 90%, right? So to get that calculation done, you are using different methods. Those will be taught to you. Right? Ashini, in descriptive statistics, we can get idea about set of data that we get to analyze, but in that we can get about the whole data. Yes. Anupama, descriptive statistics summarize the characteristics of the data, but inferential statistics is not. What? This is summarize the characteristics of data. Yes. Inferential statistics is not means. What is the other part? So Anupama, are you more clear now? Descriptive statistics summarize the data set that you have. In inferential statistics, it is not, but then what does it do? Monica. Descriptive statistic. Get basic summarized form without change in raw data. That's true. We get an idea about the whole population from not collecting data. Yes. Okay. Chamita. In descriptive set has high proof and accuracy than no. What do you mean here, Chamita, that descriptive statistics have more accuracy? You are saying it is true, the truthfulness is high in descriptive statistics because it's only applied for the data set that you analyze. Is it what you mean, Chamita?
Excuse me, madam.
Yes. Who is this?
I'm Chamita.
Yes, Chamita.
I think the most probability to accuracy in that statement I have mentioned.
Probability to accuracy is high in descriptive. Is that what you're saying?
Because the inferential means like imagination.
Not really imagination, Samita. We are using that data and there's a part that we use statistical methods. It's not really imagination. I know so if I say, is this what you mean? You are saying you get do you see the whiteboards, Chamita?
Yes, madam.
Right. So these are the values in the sample. Sample values are 10, 20, 50. 20, right? Then sample mean is, this adding up to 100. 100 divided by 4 is 25. So you are saying this is highly accurate. Their mean is 25, no? Is that what you mean by the accuracy is high? And then I am saying from this data, but inference, this is what descriptive statistic does. So in descriptive statistics, they calculate the sample mean and say the sample mean is 25. Then inferential statistic, we estimate the population mean. We don't know the population mean, so we estimate the population mean and say it is between 20 to 40, but we always say this one, there's some with the chance statement, there's a 95% confidence or chance, something like that. This is what inferential statistic would do, right? So this is the value 25 is 100% true for the sample, but that might not be 25 for the population. So you build up a confidence interval, right? and you say that for the population, not that you say, you calculate it and find out, right? There are methods to calculate this one, not that I just subtract some value from this and add up some value from this. You have methods to obtain these limits. You find out limits for an interval of values, but together with that, we are saying what is the chance it to be between this. So there's a chance that 5% probability or 10% probability for 10% chance it will not be between 20 to 40. Did I make it clear, Chama? Or shall we
Yes,
talk?
madam. I got the idea. Thank you.
Okay. So what do you mean by accuracy is that this can be wrong or false, no? Right? So I appreciate your thinking in that way. Right? Although that is not what I asked in the question, but you kind of thought a little more and say, yes, there's a chance that this can be false. But in statistics, the nice or the good thing in statistics is we say, we give an estimate for the error also. There's a 5% error. There's a 90%, this one would be 90, the error corrective probability or the chance of it to be correct is 90%. So there's a 5% error means, so there's a chance that it will not be between 20 to 40. Something like that. Right. So that's the last read was from Chamat. No? That's Chamat. Yes, then Enuri. Descriptive statistics are numbers that are used to summarize and describe data from samples about making decisions. Yes. With the help of hypothetical testing, confidence interval, there's various methods. Descriptive statistics works with small amount of data. No, Isumi, it is not. The data is same, Isumi. Our decisions in descriptive statistics only apply to the small amount of data that we collect, but the inferential statistic is applicable or can be used for the large data. Okay, Isumi? Right. Gihara. Descriptive summarizes a set of data set. Inferential statistic gives understanding. Yes, is confident data, but Inferential is not confident. Are you meaning the same as Chamatka said, Prabodha? Chamita said? What do you mean by confident? You are sure about descriptive statistic, but inferential statistic you are not that sure. Is that? Prabodha, I will leave your thing to get some input from you. What do you mean by confident data? Himasha Madhumani summarize the characteristics of a data set. Data is generalized to the broader population in inference. Yes, okay. Not that data is generalized, analysis is generalized to broader population. Vilashini. Descriptive statistic is we analyze and organize data which we have. Inference statistic is broad and help to predict future. Yes, that's true. Bihan, the descriptive set is a data on now situation summarization, but inference calculated from past and it's organized. It's not much correct. Okay. So thinking in lines of Chamit, no? So I see 3 students, Chamita, Prabhata, and Bihan, kind of doesn't really like to believe inferential statistic, whereas they have a more belief about descriptive statistics. That is true. That is, descriptive statistics are true about the sample. But our decision, we will have to go for a, rather than doing nothing, even though there's a chance our inferential statistic things can be wrong, there can be errors, but doing something is better than doing nothing. That's why we do, because we can't collect data from the whole population. Let's say it's island-wide survey, and due to practical reasons, we can't collect data from the whole population. So only thing is we can get the sample and analyze the data and use some methods and techniques to make predictions for the whole population. So it is true that predictions can go wrong, but I value your understanding on that, because otherwise people always kind of have a high feeling about inferential statistics and doesn't kind of neglect the descriptive analysis part. Then Lakmini, descriptive statistics focuses on summarizing and analyzing the visible information of a data. They focus on making predictions about large data. Good. Banu, in descriptive statistics, we find what has happened. Yes, if it is time-related data, if it is not time-related data, you would say what has happened means what the data we have. The future means the people that we have not collected data from. Give me. So I used to describe the basic features of the data and similar to make predictions about the going beyond the data set that you have. Prabodha, easy to get correct conclusion. So no, okay, Prabodha, I understand what your argument is. It's true, but our decisions might not be limited should not be limited only for the data. There are situations you want to make decisions about a larger population using the sample of data. Then mini-D. Descriptive statistics is what we really analyze. It is what we think about. It is not mini-D, not what we think. Give me a little time. Let me find you some nice explanation. No, I'll give you a small exercise and go for it. Right. It means about organizing about the whole data. That's true. So mainly it is not what we think about analysis, right? We have methods to do in inferential statistics to come to decisions. Okay, you will learn them. Kavindu, this is 100% correct and inference statistics can be correct or wrong. Okay. Meaning but inference statistics not all right. Yes. Okay, madam. My mic is not very nice. This is summarize the characteristics of data. Inferential statistics help to come to conclusions and make predictions based on data. Descriptive statistics understanding by using the data we have collected and understanding the whole situation. Good. Malsha, we can understand the descriptive very clearly and but inference statistics are not confident. Okay. I do value your argument. Descriptive statistics means summarizing the data. We can get an idea about the whole population by inferential statistics. Okay, good. So, what are the answers I got from your another answer? We are only able to describe the small population using the sample, and we can describe the large population. Right. Let me go to slides and you are slim my live children, right? So I'm putting the things that you told me, right? So the data that we use is, are you all following me, children? So the data that we use in descriptive methods is the data, that is the sample of data taken from the population, right? Right. This outline is not coming. Okay. Right. Then what is the data that we use for inferential statistics? It is the same data. That means a sample of data taken from the population. Then techniques used or the methods used. Right? Techniques are methods of descriptive data analysis, right? So you are using the methods of descriptive data analysis, for example, mean, median, graphs, those things, right? Then the techniques used in inferential statistics is different, right? We will calculate confidence intervals, which you will learn later, confidence intervals, hypothesis, testing, statistical models, right? Then decisions of those two. And here also we make decisions, no? In both we make decisions, right? True or applicable only to the sample. Here, decisions are applicable or true for the whole population. Is it clear now, children? Right? Why I use this is when I ask this question from you all, you taught in different aspects. When I ask you to openly compare the two, some people say the data is different, right? So now let's everybody have a say. So I'm comparing with respect to all three aspects. Hello, children, my good children. Now you answered my questions and I'm telling my children are good. So, do you all agree with this thing I typed? I try to change my slides to tally with every person's, because all your arguments are correct. So Vilashini, data, what I mean is data is more efficiency, or is it data or the decisions you are asking?
Yes, ma'am.
Decisions, no? Is that?
Yes, ma'am.
Not the data, right?
Yes.
Yeah, so decisions, it's different, Vilashini. I think if you want to make a decision about the population, you have to use inferential statistics, right? If you just want to understand, like say like I am going to give a chocolate to the students who are who answer my questions today. Okay, so I do the class today and find out how many students who answered the questions in the class. So there are, let's say, 100 students in the class and 10 students answered today's questions. So I need only 10 chocolates, right? Say I'm going to give chocolates on the next day also, but I don't know how many students will answer the questions on the next day, right? So I'm using methods of inferential statistics. Say today it was 10 out of 100. Then how many students will be there in the next class? We don't know how many students will come to the class also. But if you think of in terms of percentages, it's like 10%, right? Say like I want to make a estimate for the percentage of students who are answering questions next day or in general. You will use methods of inferential techniques and say it would be between some two values. For that one, you are using different techniques, and you will say that percentage will be between 60% to 90%. So you would say I will bring between 6 or 9 chocolates, right? Some chocolates between 6 or 9 would be enough, something like that. But this is 100% true that as some students are arguing, if it is 10 for the day sample, it is 10. But you can't give such 100% correct decisions for the population. We say with an error rate of 5% or 10%, the number of students who will answer the questions will be this or that, something like that. So did I get it? Did you get it, Vilashini and others?
Yes, ma'am. Thank you.
Okay. I really like myself for asking this question from you, because I understood how students are thinking, what your arguments are, so that I could incorporate all your thoughts into the lecture notes as well. So how are you all feeling? So if you are happy with what the exercise and the answers, give a happy face. There's annotations in the Zoom options are there. Is that reaction option? Right. Okay. Okay, so I'm seeing new faces. Samira, Tarindu, Janit. So good to get some feedback from you all. Right. So I'll moving